Hello, my name is Myles, and the purpose of this lab was to analyze the fundamental principle, Newton's second law, which states that the final velocity equals the initial velocity plus the total net force divided by the mass times delta t, which is the change in time. It was found through analyzing the data that the data does not fit the predicted model. Now for starters, I assume that the net force of all the pushes and pulls to be zero, represented by the third line I have here, F net equals vector 0, 0, 0. Now let's go through each of these 5 lines, which actually represent 5 lines of VPython code. The first line, ball.m equals 1, represents the mass of the ball. The ball that rolled across the desk that I analyzed using tracker was roughly 1 kilogram, which is why I had ball.m set equal to 1. The time between each frame in tracker was roughly 0.968 seconds, which is why I have the second line set to while t is less than 0.968. Now, as I stated before, my assumption, F net was 0, which represents the third line. F net equals vector 0 in the x component, 0 in the y component, and 0 in the z component. Now, ball.vel, the velocity, was calculated the initial velocity as the change in position over the change in time. I took 2 points from the data using tracker and divided by the change in time between each of those points to obtain the initial velocity. And as we know, since F net is set to 0, using algebra, you can see that the equation on the fourth line simplifies to final velocity equals initial velocity. Therefore, ball.vel equals ball.vel. And using Newton's second law of fundamental principle, you can see that the fourth line is the equation for the fundamental principle. Final velocity equals initial velocity plus F net divided by mass times delta t. Now the last line represents the position data. We have for position, final position equals initial position plus the average velocity times the change in time, which represents the last line. Ball.pos equals ball.pos, the position, plus ball.vel, the velocity, times delta t, the change in time. Using this code, I was able to construct a model that I could use to predict the change in position with the change in time, which I then was able to compare to the data, being the actual data from tracker. I will now pull up tracker and show you my analysis of a ball rolling across a desk. As we can see here, when I play the clip, the ball rolls across and I have markings set, which then give me an accurate representation of the change in position with change in time, which I then use to compare to the predicted model using my VPython code. I will pull up the graph I have of the 2 plots representing the change in position with the change in time that I can use to compare. As you can see here from looking at the graph, there is definitely a deviation between the 2 plots. From looking at it, you can say that each line is roughly a straight line. Therefore, if the line is straight, that means F net must equal 0 on both plots. So what's left to cause such an error? Well, the deviation could be a result of some slight variation in the markings made on each frame using tracker, which then would lead to a creation of an inaccurate list of position data. Therefore, in conclusion, if the markings using tracker were spot on, which most likely they weren't, then the data most likely would fit the model. Thank you.